Welcome to MCP Design Patterns, a comprehensive guide to architectural patterns for building AI-integrated systems. Today, we're exploring 6 essential patterns that solve common challenges when connecting AI agents to APIs, services, and workflows using the Model Context Protocol. Whether you're building a simple API wrapper or architecting a complex enterprise system, these patterns will give you proven blueprints for success. We'll cover the Direct API Wrapper for quick integrations, the Composite Service pattern for complex workflows, MCP-to-Agent for specialized reasoning, event-driven integration for asynchronous processing, Hierarchical MCP for enterprise-scale systems, and local resource access for high-performance file operations. Let's dive in. Direct API Wrapper pattern. Let's start with the simplest and most common pattern, the Direct API Wrapper. This pattern creates a one-to-one mapping between MCP tools and existing APIs. Think of it as a translation layer. The MCP server receives requests from your AI agent and passes them directly to an API with minimal transformation. The architecture is straightforward. Agent connects to MCP server, which connects directly to the server API. The beauty of this pattern is its simplicity. It's fast to implement, easy to maintain, and perfect when you're working with stable, well-documented APIs that don't require orchestration. There's minimal transformation logic. You're essentially creating a bridge that lets your AI agent speak the language of your existing services. When should you use this pattern? It's ideal for quick AI integrations where you need to connect to weather APIs, stock price services, translation APIs, or any other single-purpose service. For example, your agent asks for weather data. The MCP server calls the Open Weather Map API and returns the result. Simple, effective, and reliable. The key benefits are fast implementation, low complexity, easy maintenance, and stability. This is your go-to pattern when you need to get AI capabilities connected to existing services quickly. Composite Service pattern. Now, let's step up the complexity with the Composite Service pattern. Unlike the Direct API Wrapper, this pattern orchestrates multiple APIs to provide higher-level capabilities. Your MCP server becomes a conductor, coordinating calls to multiple services, combining their data, and presenting a unified interface to the AI agent. The agent makes one request to the MCP server, which then intelligently calls multiple APIs and synthesizes the results. The key characteristics are multi-service orchestration, data aggregation, transformation logic, and workflow abstraction. You're essentially creating new, higher-level capabilities by composing existing services. When do you use this pattern? When you have complex workflows requiring multiple services, when you need to aggregate data from different sources, when there's business logic that needs to coordinate multiple systems, or when you want to provide simplified, high-level operations to your AI agent. Real-world examples include travel booking systems, market analysis tools that combine stock data with news and sentiment analysis, or customer profiles that aggregate data from CRM, support tickets, and purchase history. This pattern might seem complex, but for large organizations with multiple teams and domains, it's essential for maintaining sanity and enabling independent development. MCP-to-Agent pattern. The MCP-to-Agent pattern introduces something powerful: AI agents calling other AI agents. In this architecture, your MCP tools invoke specialized AI agents for domain-specific reasoning. This enables truly modular AI systems where different agents handle different areas of expertise. Your main agent recognizes it needs specialized knowledge and delegates to an expert agent through the MCP layer. It's like a general practitioner doctor referring you to a specialist. The main agent handles general tasks, but when it encounters a legal question, it calls the legal specialist agent. When it needs financial analysis, it delegates to the financial expert agent. The flow works like this. Agent makes a request to the MCP server, which routes to the appropriate server API, and that API coordinates with the specialist agent. The specialist does its reasoning and returns results back through the chain. This pattern is ideal for complex problems requiring deep expertise, domain-specific reasoning, modular AI system architecture, and when you want to optimize different models for different tasks. You might have a fast, efficient model for general queries, but invoke a larger, more specialized model for complex analysis. Use cases include legal contract analysis, where a general assistant delegates to a legal specialist agent, medical diagnosis systems where a triage agent routes to radiology or pathology specialists, or financial planning where you have separate agents for tax optimization, investment strategy, and retirement planning. Event-driven integration pattern. The event-driven integration pattern is all about asynchronous, non-blocking workflows. Instead of your agent waiting for a response, the MCP server publishes events to an event stream, triggering asynchronous workflow processing. This is perfect for long-running tasks, real-time data processing, and high-throughput scenarios where you can't afford to block. The architecture flows: agent sends a request, MCP server publishes to an event stream, and asynchronous workflow processing handles the task in the background. The agent can continue working while the processing happens independently. Key characteristics are non-blocking execution, event-driven architecture, asynchronous processing, and the ability to handle real-time data streams. This decouples your components, making your system more resilient and scalable. When do you use this? For long-running background tasks like video transcoding, real-time monitoring and alerting systems, data processing pipelines, or any scenario where you need high throughput and can't wait for synchronous responses. A practical example: an agent uploads a video for processing. The MCP server publishes an event to the processing queue and immediately returns. Background workers pick up the event, transcode the video, and notify the agent when complete. The agent never had to wait. Hierarchical MCP pattern. For enterprise-scale systems, we have the hierarchical MCP pattern. This pattern organizes MCP servers in a hierarchy, with a top-level domain server managing cross-cutting concerns like authentication and routing, while subdomain servers handle specific business capabilities. Think of it as an organizational chart for your AI architecture. The structure shows an agent connecting to a domain-level server at the top, which then routes requests to specialized subservers: customer MCP, wallet MCP, payments MCP, and so on. Each subserver is responsible for its domain and can be developed and maintained independently. This pattern is essential for large enterprise systems with multiple domains, clear team boundaries, and complex authorization requirements. It allows different teams to own their domains while maintaining consistent governance at the top level. Key benefits are enterprise scalability, domain separation, team autonomy, and centralized governance for cross-cutting concerns like security and monitoring. Real-world examples include e-commerce platforms with separate servers for products, orders, customers, and payments, banking systems with accounts, transactions, loans, and card subservers, or healthcare systems with patient, appointments, billing, and medical records subdomains. This pattern might seem complex, but for large organizations with multiple teams and domains, it's essential for maintaining sanity and enabling independent development. Local resource access pattern. The local resource access pattern brings AI capabilities to your local file system. This pattern provides secure access to local files for document processing and analysis without requiring external API calls. It's perfect for sensitive data that can't leave your system, high-volume file operations, and offline or air-gapped environments. The architecture is unique. An agent works on a task like file processing, and the server directly accesses the local file system through a local MCP. There's no external API dependency. Everything happens locally for maximum performance and security. Your AI agent can process documents, analyze data, and work with files even without internet connectivity. When should you use this pattern? For document analysis workflows where you're processing PDFs, Word documents, or spreadsheets. For sensitive data that has compliance requirements preventing external transmission. For high-volume file operations where API latency would be prohibitive. Or in offline and air-gapped environments like secure government or military systems. Examples include document analysis where an agent processes local files, log file analysis for troubleshooting, or data science workflows that process local CSV files and datasets. This pattern offers high performance, offline support, data security, and zero API costs. Pattern Selection Guide. Now let's talk about choosing the right pattern for your use case. Each pattern has a complexity level and ideal scenarios. The Direct API Wrapper is your simplest option, 1-star complexity, best for simple, stable APIs when you need quick integration. Start here if you can. The Composite Service pattern sits at medium complexity, 3 stars, ideal for complex workflows requiring multiple API orchestration.
Use this when you have complex workflows requiring multiple APIs and when you need to aggregate data from different sources. The MCP-to-Agent pattern is high complexity, 4 stars, but necessary when you need specialized domain reasoning. The added complexity pays off when you need genuine expertise. Event-driven integration is medium complexity, 3 stars, perfect for asynchronous workflows when non-blocking execution is required, essential for background processing and real-time scenarios. The hierarchical MCP pattern is the most complex, 5 stars, but absolutely necessary for enterprise systems with multiple domains and teams. Don't use this unless you need it, but when you do, nothing else will work. Finally, the local resource access pattern is low to medium complexity, 2 stars, ideal for file operations and local data processing. It's simpler than you might think and incredibly powerful for the right use cases.
Best practices and key takeaways.
The key is matching
Let's wrap
pattern
up with best
complexity to
practices
your
and key
actual
takeaways.
needs.
First, design principles. Start simple with a direct API wrapper pattern and add complexity only as needed. Don't over-engineer from day one. Respect separation of concerns. Each pattern addresses specific architectural needs, so choose thoughtfully. Remember that patterns are composable. You can combine them for complex systems. And always choose patterns that scale with your needs rather than patterns that create technical debt. For implementation, put security first. Validate all inputs and secure your API keys. Implement robust error handling with graceful degradation when APIs fail. Add comprehensive monitoring to track performance and usage metrics. Document everything. Clear API contracts and examples save countless hours. And never skip testing. Comprehensive unit and integration tests are essential for reliable MCP systems. The bottom line, these 6 patterns give you proven blueprints for connecting AI to your infrastructure. Whether you're building a simple integration or an enterprise-scale system, start with a pattern that matches your needs and iterate from there. Thank you for attending the session. Now, go build something amazing with MCP.